Okay, so my name is Joost. I work at Joost van Oijen. I work at VSTEP. It's a company that creates virtual training simulators. And also a PhD student at Utrecht University, where I try to do research on how to apply behavioral models into virtual worlds. So that will become clear a little bit later. So I will try to focus on the work that we do at VSTEP in the area of crowd simulations and crowd training. So just a little bit about VSTEP, a company established in 2002. We're situated here in Rotterdam, about 50 staff members. So we focus on applications that would facilitate organizations to train their personnel on certain skills in a safe and cost-effective manner. So what that means is by training in virtual environments instead of in real worlds, we try to be able to train personnel on certain skills or for certain scenarios that wouldn't really be possible to train in the real world. So for example, large incidents, and especially for crowds, it's really difficult to do real world training with crowds because you need a lot of people. So if you can simulate this and also have an effective training environment in a virtual world, this would be suitable. So, short on some of our products to gain a little bit more insight into the kind of trainings. So, for example, we are making maritime simulators, so it's for maritime personnel to learn how to operate, for example, ships. We have emergency response trainers for firefighters, police departments, ambulance personnel. So here they can create all kinds of incidents in all kinds of environments to train on their procedures, for example. And for the crowd related, we have two products, iObserve and the crowd control trainer. So I will focus mostly on those two. Actually, mostly on the last one. But a little bit about iObserve because it's also crowd related. So it's a trainer for surveillance camera operators to try to identify suspicious behaviors in large crowds. So for example, in the city center of Rotterdam, there are thousands of cameras, and there's actually a control center where people are watching all those cameras and try to see what's going on, are there any suspicious behaviors going on. So this is perfectly something we could try to simulate also and make a virtual training out of it if we can make this environment as realistic as possible. So some of the incidents that we can create, the scenarios, is things like drug dealers or pickpockets, try to identify them in the crowd, or someone leaves a suitcase somewhere and it's suspicious. So these kinds of scenarios, and at the moment there are the city, I call it Stadstoezicht Rotterdam. They're actually training with the software to not only to operate the cameras, but also try to be better at following people from one camera to the other and trying to see if they can learn about suspicious behaviors. So the crowd control trainer, I'll give a live demo afterwards. But a little bit about it, it's an SBIR project, so it's a small business innovation research project. It was subsidized by the Ministry of Economic Affairs. So it was done in collaboration with the police department, so together we tried to see what kind of training needs they have and how we could create an interesting trainer for them. So here the goal is to train the decision makers in the area of crowd management and crowd control. So the important parts here is the planning and the preparation of demonstrations, big scale events. So also during our talks we talked about all these events, the Project X in Haren, Helle, Hoek van Holland, Love Parade. These are all kinds of examples that triggered the need for these kinds of trainings. I'm not saying we can currently effectively train for these situations, but as we will see later, there's definitely at this point already a lot of training possibilities in these virtual environments. And one of the most important things is for them to increase the quality of the decision making and situation awareness. So the target group for this product was mostly the riot police commanders. So they have different levels of commanders. There's like the group commander, they have a control over I think seven riot police officers, and 3 of those units then become a section, and there's another commander which gives lead to that section, and for 2 sections you have another guy on top, and so you get towards a more strategic level, and this trainer would be more at a strategic level and less at the operational level, because that's very difficult to train in a virtual environment, because the environment needs to become really realistic, and especially if you need to act in it. So it's training for more at this strategic level. Yeah, so currently they're using it, they're evaluating it. So we delivered it in the beginning of this year, and they're trying to see if they can integrate it into their training program for the riot police. So I'll just go to the demo. Perhaps there are questions so far, you can just ask. So I'll try to, I think I'll try to highlight 2 things. So one thing is the simulation abilities that we have to simulate crowds and their behaviors. And on the other side, the training value that organizations might have with this kind of technology. Is it good to see? Or perhaps put the lines. It might be a little bit better.
Find the lights?
No, it's not that big of a deal.
I'm afraid they switched on and off automatically.
Yeah, we can see it
But
pretty
we
well.
can see it's okay.
Yeah? Okay, that's fine. Okay.
Maybe if we all don't move.
And wait half an hour again.
So we simulated a part of the city center of Rotterdam. You see here the central station. It was already long in the simulator before it was actually built.
You can finally use it now.
It's also one of the advantages of the simulations. So to get a sense of the scale, so you have here the Weenagelplein. There's a square here which is quite detailed. So this would be like the playground for the scenarios, for the crowd-related scenarios. So of course, if the police department of Amsterdam would like to train, they of course would like their own environment to play with. But to give you a sense, this would take, for development time, about a couple of months, 3 to 4 months for one person to create such an environment. So perhaps a little bit about how the training would look like. So this is the view that normally an instructor would have. So usually there's an instructor and a trainee that needs to be trained. The instructor will create the scenarios, so he can populate the environment with all kinds of objects and the crowds. So he can prepare a scenario beforehand. And during a training, he would also have this view and be able to control people in it, and also the riot police units in the environment. A trainee, on the other hand, so we can put a trainee in the environment. The guy. He would normally, like you have it here, in a projector screen, and he would stand in front of the screen and would just see it from his own point of view, like he would in real life. So he would just walk around in the environment, look around. So this is how he looks like. And of course, currently we're also looking at other ways in which the trainee would be inside the environment. So we also have virtual reality glasses where you can really be immersed in the environment. Everything is full 3D around you. At the moment, there's not an affordable virtual reality glasses on the market, but next year there's a really promising product which and we're really looking forward to integrate this in all our trainings. It might be very interesting, at least the visual realism is already good enough for you to be really immersed in the environment, but then again, as soon as it becomes very realistic, you also need the crowds to be very realistic around you. That might still be a problem. So I'll just show you the crowds. So we can make as many groups as you want, and we just say how many people you would like to have. Of course, there's a limit at the moment, depends on the hardware, but it's now about 1,000 people you can put in the environment. So let's say you just draw an area and the crowds will be.
It's more like an army.
Yeah.
So together with the police, we looked at a certain type of appearances of groups that they would like to have.
What's the difference between a left-wing group and a right-wing group?
Clothing.
Is it haircut or something? Length of hair.
Actually, it's the left-wing group is a bit more colorful. That's the difference here. Yeah.
Makes sense.
So that's just now. It's just mainly for the visual distinction. So also in the future, of course, we would like to be able to give them actual profiles, like that the hooligans would actually behave like hooligans. At the moment, that's still a step too far, and that's also a bit about my research, what I'm doing there. But for now, it's for these profiles, it's just purely visual distinction. There are also certain attributes you can just basically customize them a bit. For example, you can make them a certain demonstration crowd, give them some demonstration boards where you will start demonstrating. Some other things, for example, you can equip them with certain weapons or sticks, facial covers. Or some flares, some fireworks. So these are just some examples that we negotiated with the police, like what do you think would be interesting to have in the simulator that would be valuable for training. So these are all introduced purely for that purpose. So for example, when the riot police has a scenario, they need to guide a demonstration. Sometimes they have these rules like we don't allow protest boards, or we don't allow facial covers. So that would be like a training value. If a trainee would actually see that, what would be his decision to make? We also have, for the same reason, a couple of behaviors they can perform. So, for example, it might be better suited for this crowd. You can introduce a small, for example, a small fight between some people. You can have a person throw some fireworks. Or you can have some people throw some rocks.
Not strong enough.
So for example, again purely for certain training opportunities, the fights, it doesn't really matter if it's not that realistic or they keep fighting like this. But if from a trainee perspective, yeah, you might from a distance see some kind of fighting going on in the distance, and then okay, it will be another trigger, another training situation. What would you do in such a situation? Do you order a unit to go there and intervene, or do you just kindly ask them to stop, or what are you going to do?
It is also possible to see the impact of the decision you make on the behavior of the hooligans.
Yeah, there's some small interactions between the actions of the riot police and the crowd, but it's quite limited. I will show that later. So these are just small examples, but actually the most important thing for the riot police is like movements of crowds. So how do you prevent that two groups that might come together that you need to keep apart, or how do you deal with if in a demonstration people are walking and suddenly 5 people run in some direction, how do you deal with that? So these are more interesting scenarios for them. So a lot of time was also spent on the navigation possibilities for the crowd. So you can, for every group you can send them to some location, and they will start walk over there. Or they can run, or things like that. To show you a little bit more about that, for example, if we have 400 people over here and over here, and if you, for example, would let them walk in opposite directions of each other. So we have to make sure that the models of where the people need to avoid each other are realistic. So you see these certain streams appear also, like it will also be in real life. So you don't want the people to walk straight through each other, but you need some kind of more of these lower level models of how people navigate through the environment. A similar situation, for instance, if you put let's say 1,000 people in this area, it's a bit hard to see here. And if you would send them to a different part of the city, for example, they will go somewhere in this area. So each person for himself will individually try to find an optimal route how to reach his destination. So you would see certain streams of people appear. Some people decide to go.
So would you be able to model the patterns like we saw in the Duisburg video? Or
yeah, that's an interesting question. So actually there is research where they try to see, they try to model the crowd in a simulator in a certain way, and if that model is right, they can try to apply it to different situations and see what happens. For the love parade situation, I haven't actually tried it, but if the forces become too big, I think here the people will just will go through each other eventually. But I think you would be able to make to make certain. Yeah, it's difficult to see. You need to have a good model, and then you can try to see if it matches like in the real world, and see what you can learn from that. But this kind of technology is definitely used also for example, for planning the design of big football stadium, if the design is correct, and analyze flows of movements for crowds. So these are also based on this kind of technology. But they can also dynamically be influenced by certain blockades, for example. You can just put certain fences, and the people eventually go to find another way around it. So if you put a fence here, the people just decide to take another route. They probably go all the way around. So this is a little bit about the possibilities of the crowds. I can now try to explain a little bit more how they actually train with the simulator. So we developed one scenario together with the riot police. And it's about a demonstration that needs to be escorted along a certain route through the city. And there's a conference going on in the Manhattan Hotel, and people are not allowed to go near there. So these demonstrators are also demonstrating against the people that are holding the conference. So how a training would look is a training would just be confronted with a use case, like it would in real life. Okay, so there's a demonstration is planned. We need to go there and maintain the order. So what's your plan? So the trainee needs to be able to plan how he wants to prepare the environment for this event. So for example, what streets are you going to close off? What would be the presence of the riot police? Do they come in full uniform, or do they only have a polo on? Also, yeah, just to which of course could have an influence on the status of the crowd, the emotions of the crowd. At what kind of strategic positions are you going to put your riot police units? So for example, in this case, the demonstration that is planned will go from this route here to the square. So for example, they could say, okay, I will put the riot police unit over here. Let this unit patrol in a certain area, for example. You might want to close off this street, so they can put, for example, some police on horses. So there are a couple of these resources or units that they would use in real life. So these are.
And have you then modeled how that would impact the behavior of the crowd, or does it stop here?
Yeah, there's a little bit of impact, but it's not very extensive. So one example of the interaction is you can, for a riot police unit, you can make a certain front line in front of a group of people, and can move the front line a little bit to the front, and the people would go back. But it would be, if you want to put more intelligence in there are basically two problems. The first one, if we put the intelligence inside the software, which would often already be very difficult, because if someone will throw a rock at you, what kind of behavior do you give the person? How does he react to it? Basically, you're trying to model human behavior, and of course that becomes very complex. You may have it in in a small domain, you might be able to program certain reactive behaviors or believable behaviors, but the domain quickly grows very, very large and it becomes unmanageable. And the other part is that usually the instructors want to be in full control over what happens. So for example, if you try to make a certain, if the trainee gives an order to have a unit perform a certain measurement, it may be a good or a bad decision in that case. And it's really difficult to put that kind of intelligence in the simulator. You probably also don't want that, because for many situations, what is either good or bad in a particular situation, even experts, they don't always know that and discuss that with each other. So usually the instructors would like to be in control, so if the trainee makes a certain decision, the instructor would basically control the crowd in a way that he wants. So he is in control over the reactions of the crowd. But to some degree, for example, if the horses start running through the crowd, people will try to run away. So, of course, these basic behaviors we can do, but even then it can already lead to some undesirable situations. Yeah, actually, I might also run out of time, so I don't think it's useful to show the whole training. But perhaps, yeah, I don't know. Perhaps I can try to show some things if people would like to see something or have additional questions about possibilities.
Yeah. How is the gaming technology perceived by the people who are using it? Do you find that they find it too technical to use, or are they really enthusiastic about its use?
Yeah, you see a very big difference between the younger people and the older people. So we had two instructors that we, for example, needed to train on how to operate the system to become an instructor. And there was an older man. He had a lot of difficulties, for example, with even navigating through the environment or working in this kind of 3D setting. And some of the younger people, they quickly adopted. So that is a challenge. We do need to train people to operate it. And the challenge is to make it as easy as possible. So you don't want, as an instructor, to specify exactly these people should go in the car and then they should go there. We try to make more high-level commands available to them that will be automatically applied in the simulator.
The virtual reality game I show, it also has a logging system where people get logged with the avatars. We know where they work. Is it also possible with this system that you know where all the people are and that you can do later analyze the data? Is that
so it's not in this simulator, but in some of our other products.
Mm-hmm.
It's usually what they call a session recording. So for a whole training, record every step. So you can, whenever a trainee, for example, makes a certain important decision and he makes a wrong decision, afterwards you can just scroll back to exactly that point and you can start the simulation from that point on. So inherently then also all the states of each time step of the simulation.
That's great. You can also just retrace the steps and you can also see it again what they did.
Yes. So we also had some research to try to put in more of this, also these psychological things. For example, one person was working on if there's a big fire somewhere, how do people run away from it? she was also working with these leaders and followers to try to simulate that also in the virtual environment. So there's also a lot of people working on these kinds of things for virtual trainings. For example, also how emotions spread through big crowds, these kinds of things. It's quite an active topic also in this research community.
So would you say the main obstacles to developing this are the budget? Is that the main thing? Are there any kind of, is it actually the technology hasn't yet? Because I sort of think that the American military, they started using Call of Duty rather than their own simulations because the budget was such different that they could never ever compete with their own in-house productions.
Yeah, it is.
Is that the main kind of problem with taking it to the next level, or is it?
Yeah, there are a couple of factors. So this was kind of a small project, but also it's only one environment. The content is not that high here. For example, you see military organizations, most of them worldwide use a single product, which is called VBS2. So also the Dutch military is using that, for example. They can share all their environments between each other. So if one military organization requests certain units to be available in the simulator, also all the other countries get it. So that's a huge advantage there. But they also saw some of the problems. Well, in that software we cannot create more than 200 people for our crowd. So for every different type of situations, you might need different kinds of software, and it's difficult to see how that works. Large obstacles further here would, I would say the biggest challenge is to see how far you can get with the artificial intelligence, to make the crowd more intelligent based on psychological behavioral models, and the design. So you can spend a lot of time in designing behavior for a certain domain, but if you then want to go to a completely different domain and also want to apply these kinds of behaviors or different kinds of behaviors, the problem is that it's hard to reuse certain models across different domains. I think that's